In the lab we did the same experiment, measuring force versus ramp slope. We got data points. We got a straight line fitting those data points. This particular line doesn't fit these data points particularly well. If we sloped it this way a little bit more, we could probably just about hit all three lines, but I wanted to emphasize that even the best fit line doesn't necessarily go through any data points. We calculated the slope of that graph by picking 2 points on the line, not graph points, and taking the rise and the run between the points. Forces were measured in newtons. We were using balances that measured force in something called newtons, and we'll shortly see what the definition of a newton is. Ramp slopes went up to about 0.1, so I arbitrarily put a 0.05 down here just to indicate the magnitude of the scale of the ramp slope. The slope is going to be in rise units of newtons divided by run units. There are no run units. The run is unitless because when we calculate the ramp slope, we're dividing centimeters of rise by centimeters of run, and they cancel out and we end up with no units. So that the rise of this will be in newtons. The straight line, again, is found to have a slope very nearly 5 newtons. And the force is going to be 5 newtons multiplied by ramp slope plus a constant. The constant corresponds to the fact that the straight line doesn't really go through the origin. I drew this one through the origin, but the straight line we got in lab really went through a point about here on the horizontal axis.